Today's education at every institution on each level, every student is entitled to go for internship training. As archbuild construction consultants, we usually have only 10 slots reserved for those lucky students who can be able to participate in internship at our office. This year, we have got this class from different universities, KIU, Chambogo, Ndeje, and other institutions to participate in our internship. And we have the final assignment for internship, which is setting out a house using a 3-4-5 method, one of the easiest ways you can set without a square, just using engineering principles. So that is the assignment we shall all cover, and this is the team. Each one will be assigned what to do. We have ladies, gents, and me who will be guiding them to do that assignment. The ladies are going to buy some things. Also, gents are going to buy some things because you have to use your own materials for setting out. But one of the cores is we are going to have a simple plan which we are going to set out in the next steps so that each person can always remember that process as he goes on his education system. Thank you. Let's start on that. We are going to create here using our panga. So what about the panga? You are going to use it to do that. Yeah? Who's the first? Ladies first. Hey, get this and start doing that.
Make something like that.
Yeah, we are making our pages because we have finished creating the props. I don't put on that sheet, it's going to get the further. Rather get another and you put there, or you put it down, whichever that is easier. Here we need the boy. Someone must sit you in. So we are now making pegs. So because we have no time, another person can try out this methodology and we see. You cut at an angle. Eh? See, in engineering you have to just be creative. Eh? Someone can come and finish at an angle. Yeah, enough. Another one can try. We are learning how to cut on an angle. That's enough. Have materials you're going to use. We have seen the materials you need. At least you need a panga. We have used it. Yeah. You need a hammer. whoever brought this hammer, this is it's a serious hammer, but we need the real hammer, which we are going to use. Then we need nails. This is good, which we are going to use. Then we need a rope, which is going to help us in setting out. So those are some of the things we need. As an engineer and also a tape measure, we need to be creative when you're doing things. Most of the times, clients don't have money, don't spend a lot of money buying everything. So you can use the little materials you have to set out. So those are some of the materials we are going to mobilize on to do our setting out. So those are the materials. So now, step one, you have to get what they call a reference point. A reference point or a benchmark is where you are going to always refer your new structure vis-a-vis the points. There's always a point where you mark, or you find the roads they have marked. We call it a benchmark. So in a house also, when you are setting out, look for a place where you are going to always remember that my house started from here. So that when you get an error, you know where to start correcting it from. Many people start and he reaches here and you start putting up the poles. If there's an error, you don't know where to start. You find you have to start everything. So with our simple house, which is a 4.2 by 3.4 loom, we are going to use this existing office of archbuild as our benchmark. So we are going to assume that from that office, we want to leave 3 meters between this structure and this. So it is what we are going to now measure as our benchmark. Because it is there, so we can always know. Whenever I have forgotten where I started from there. 3 meters here, 3 meters there. So I have a first straight line with 3 meters of the structure. So let's do that. Action, we do that. Someone measures there 3 meters. Put down, make sure it is straight. Now, if you're setting out, make sure your tape measure is always on the same level. Okay? It's always on the same level. If it is that, you can move a bit, because the moment you put an angle, it's not so perfect. Now, if you are, now someone come here, you come and put there this in condo here, but make sure you're careful with this. That's why he's putting on an element. Don't forget to make sure it is straight, like this. If it is straight here, I want everything to be in line. We want to measure this to be having a 90 degrees here. So you put there, you measure, then you put there that straight line. You feel that's 3 meters. Hey. You're going to set out, you have to eat something because you need some energy. So I always want to test myself. You get this other tape measure, you again see whether it is 3 meters. Move up, make sure it is straight on this level. Move it up, a bit up, no, make sure it is straight. Straight, down, somewhere like there. So I confirm this is 3 meters. So I go to the edge, we are looking for a bench. Bring that in corner there. This is my 3 meters. It's around here. Yeah, you can put there. Make it strong a bit. So this is our reference point. It simply means that between this and my new proposed house, possibly according to our architecture, they want 3 meters between those two houses. So my house is starting from here, going in this direction, altogether. Whatever I know, my wall is going to be starting from here, going this direction. So meaning this is the center of this pole where we're going to mark with a nail is the edge of the external parts of the wall. The house starts from here, they do brick walling going this side, and they go to this direction. So what we do, we go here. Be careful when you are hammering the nail. You can hammer here. It's very dangerous, eh? Be careful. When it enters, try to move the hand so that you hammer properly, and it should be straight, eh? That's enough. Someone can also go and hammer. You have done too much. Grace, go and hammer. That side. Going this direction, eh? You have got the benchmark. So the math is going to start from here, going elsewhere. So we have our benchmark here. It's very crucial. Hey, I'm running faster than the rope. Then you open that as well. From this house, eh? So I have my 3 meters here. Now, I want first identify the first corner of the house. The first corner what? Of the house. So usually they give you what they call an offset. What is the distance of the house from the boundary wall? What's the distance from the boundary, either from the other existing what? Structure, eh? For example, if this is my existing structure, there's a minimum distance they want. Eh? Minimum should be at least 3 meters. Then from the boundary wall, there's what the council recommends. Eh? So usually they don't want anything less than 1.2. But based on our entrance, we might find that if we put 1.2, the house might enter that corner. Eh? So in architecture, you might find that we need like, from there up to here, we need like 4 meters to have our house get started. Yeah. So you are going to measure following this wall from that side and we identify 4 meters, which is the offset from the boundary wall. Eh? So you use that long-term measure. Where could be 4 or 3 meters around there. Let's measure. Make sure it is straight with this rope, eh? Because already we have got this benchmark from this side. Eh? Possibly our 4 meters, let it be straight, don't force it to be straight. Eh? Let it move, let it be straight. So our 4 meters are here. Eh? So we have identified our 4 meters. Eh? So meaning that our house is going to start here. Going this direction, starting from here going to this direction. All together, eh? So we are going to create the first square of this house, keeping this reference point constant, using a 3-4-5 method. Now, we are going to do that. Now, mathematically, what we want is we want to create a new line at these points, going in this direction, also have this kept constant. We want our square to have a 90 degrees here. Eh? So, if you use a 3-4, I've told you that, of course you must always have it right when setting out. A 3-4-5 method, we mean that this is 3 meters here. Then here I can move 4 meters. Then I have got the pythography here. It gives me 90 degrees. Yeah. So now, I told you that the simplest way we can do it, we have a 3 plus 4 plus 5, eh? Implying that this is 7 plus 5, which is 12 meters. So I need a tape measure which is 12 meters to have that achieved. Yeah. So these people first move 12 meters, then we make our square, which we have already practiced. 12 meters, then we have someone stand on the 3 meters, another one on 4 meters, another one on the 12th meter. You can first move freely. Someone should be on a 3 meters, so that you don't move far. You first come this side. Madam, you can move their direction with your 3. Yeah. Then the next person goes on a 7. Make sure you don't touch the nail. You touch on top like this here nearby. Then this person goes on a 7. Leave the rope here. Don't touch it. Just be on top of it. Then for you, look for the 12. Look for her. This is 3 here on this corner. Move it properly on top of the nail. Yep. And make sure they are tight. Make sure you pull them so that it is tight. All together. Now, using this method, this is a 3, 4, 5. This is 3 meters. This is 4 meters. This is 5 meters. Yeah. So implying that this one mathematically using Pythagoras theorem, it is a 90 degree. All together. So what we are going to do, someone is going to get a pole. Don't go away. You make sure you go where she is and put the pole where she is. Some pole there. Hey. And you first locate that place. Isn't it? Now I'm going to measure the external dimension because we say the house is starting from here going inside. So we are going to measure the external direction for this direction, which is according to our simple plan, say 4.2. You come with a 4.2 from here, measure 4.2 the other direction. 4.2. 4.2. Let's go. It's here, We are still on our reference points. So our 4.2 is, make sure it is straight and don't touch the rope. Make sure you're on top of it. Move down. Make sure it is not sagging. Now you pull properly to go with the rope. Yes, now move on the rope. Identify your 4.2, yeah? So my 4.2 is here. So I've got the number 2 point where the house is starting. So my house is starting from here, going inside, also starting from there, going inside, yeah? So I want us to also create here a square using a 3, 4, 5 method. Same methodology. We have someone moving there 3 meters. Here, someone moving 4 meters, then with a 5. This time it is boys. Girls did their 4-2 thingy. So I need someone with a 3 to be the one here. If you get a 3, be one here. 3 meters, be the one here. Then look for, for you have your starting point here. Someone else should be there and look for a 7. And where it is, you get it. Three, 4, 5 method. You bring here where 12 is. Now make sure you are straight. You pull each one should pull him the other way. So we are saying with this method, we believe that this one is still loose. You move. Put here. So you be the one to move and make sure you are touching the where is the what's the 12 is touching here, and like this, you pull them. So we believe that using Pythagoras theorem, if here you have 3, 4, and this is 5, yeah, that's a 90-degree here created, yeah, using this methodology. So it is here. So someone should go there and put there a pole. What corner? You put on top of that a nail, because now we are going to set another thing. Make sure you check this thing has moved, it should be around here. We're putting on top, 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 top. And don't touch there on the reference. Put our nail here at this point. Be careful when you are doing the heating. Now, we are a bit careful because we want first to confirm the squares of the house before we do anything else. Many people start setting out and you find that squares already have failed, even when they have not gone. You find the whole day you are repeating the entire squares. So we are trying to first get the squares of the house. Now, you are the one going to put that one there and him, like we have done here. You get a condo here, then we set up that so that we have that. On top of the nail. First move and make sure it's on top, so that you make sure that it is in between. So for him to be positioned so well, you again move on top and make sure it is the line, then you can see where he positioned, then you can hit from there. Soko kubi nkondo. You're still in line with the, sure you are very, very careful. Is it an engineering eye? Yeah. Again, you check to ensure that it is. Make sure it moves until it's in line.
It is now. It is now. Go back now. It is now.
Yeah. So you highlight that. So sometimes we usually prefer for accuracy. You come, make sure that it is here. So now you have to cut from here. You measure your nkondo, or either you move it further inside by this distance so that you can get properly. You see now it should be around here. Here I can tie it here, so long as it is in line. You tie, so that it is in line properly here. We are going to again make checks. What's our tape measure? Tape measure is where I want to check from here up to here. Is it still 4? We had the what? A 4.2. Confirm that. 4.2. You come and check. They are going to give you wrong things here. 4.2. Now, here, because now we are sure here there is what? And we have a 90 degrees there. Even the other side we have got a what? A 90 degrees. Now, here I want to look for 3.2 and we put a nail going up. Look for a 3.2. And you go and put a nail there. So you measure 3.2. Make sure it is straight, it's sagging. Pull, 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 pull. Highlight that and you put that. 3.2. Do the same. 3.2 the other direction. No, here we are using this where we are sure of the square. Here 3.2 is discussing. Make sure you are putting on top of this. And make sure it is straight. You make sure it is straight. Pull. Make sure you pull. Look for 3.2. Yeah. So now, according to our method, we have a 4.2 there. We have got a 3.2 here. So now, this is the row. You can come and see here. Come and see what we are going to do now. We have this. We are setting. We have this outside. You see, we have this as our external wall. From here up to here. As a 3.4 meters. Then we have here up to here as a 4.2. Isn't it? Now we are going on the final tests of a 3-4-5 method. Yeah. Diagonals from here and diagonal this from here up to here. This is diagonal 1 and diagonal 2 must be equal. That's the final test. You can even calculate the diagonals because we know that 4.2 squared plus 3.4 squared is equal to diagonal 1 squared. Yeah. So diagonal 1 is equal to the root of 4.2 squared plus 3.4 squared. So diagonal 1 equals, an engineer must have mathematics in the head. Hey. So we want to test the law of diagonals. Two diagonals must be equal and we should also have the distance. Someone gets 3.4 squared. That's for what? For both? Yeah. Answer when it is finished. It is 5.4 meters. So this is the diagonal. Yeah? So let's measure. You are touching the rope. You go out. You just off the rope. Remove your hips from the rope. And you make sure you put here. Something like that. This is a 5.3, which is okay. Then again you measure from there. From there up to here. Pull. It's a 5.28. There's a small what? Error. Hey, you're touching the rope. Now you touch for yourself, yeah? So now we have a, here we have got a 5.3, yeah? Here we have got a 5.26. We have got a small error of 0. What? 0.4. Eh? Of course, you can rectify it through a little movement of this rope here, just slightly. It's a very, very small what? Difference pull. You pull. So you can just correct it a bit by moving this a little. I don't move so much. So that we correct that error. Eh? Then after that, we measure again from here up to here. If we still have the same distance, it was a 3 point what? It was a 4.2. So here, move it slowly. It's there. Stop there. That's perfect. Then again, you measure from here up to there. You have to make sure that all the dimensions of your house are clear. It's a 4. It's a 4.2. It's there. So now we have our dimensions all controlled. Eh? You make sure that after you have set all that, the diagonals are equal, yeah? Then you again make sure you measure all your measurements and make sure they are as on the plan. Are we together? So, we are going to have our last rope that is going to move. Don't tamper with our square. It is going to move that rope from that point up to here. Our lasting condos to ensure that we have these reference points reserved. Eh? So after that, we are going to go on the final thing. We're going to go on the final assignment. You put this on the finalize. Can you get others? Now, the last thing, assuming we have finished this, we are going to, now we have got, assuming this is done, you put there whatever you put. I'm going to show you. They will shift their things. You put there, I give you the last thing. Actually, to extend behind a bit, because we are going to add the lasting cone of excavation here. Now, let me explain to you the last step. Eh? Now we have got, assuming now you have understood, this is now our square, eh? Which we have got. You can put and we tie and we. Hopefully you guys finish. I want to give you the last thing of the lasts. Tie it, already I've got the squares. Eh? Please, you come here and we have the final assessment of our methodology. Eh? Come behind, don't go in the front, so to see properly. So based on what you are seeing here, we have used our 3-4-5 method to try to acquire the squares, and the external part of the entire plan which we have here has been set. You can see it. So these are the references which show the squares of that. This message also has some problems, yeah? Because you're a human being, you have errors. Where you are supposed to put it straight, it moved at a certain angle. Eh? So sometimes you find you have got some error. But we usually say that an error should be minimal. Eh? It should be a 0.00 something, yeah? Don't have an error, you find that your diagonal is diverting by 5 meters. That's dangerous. You have to repeat everything. Eh? There should be some minimal errors controlled. Then later, when we are setting out, sometimes we have a square we use. Make sure you again check all your diagonals using the square. Eh? It's the true that there's a metallic square we use to ensure that everything is perfect. All together. Eh? Then after you have done this, I have got my square of this entire plan we had here in our training. The last of the last things, we are going to create what they call excavation of the foundation. That's the last part. So the excavation of the foundation, we are going to use a profile. We are going to have, I know my foundation is going to start from here going inside. All together, eh? So from here you're going to have a profile that is going to move like this, yeah? All together, eh? So what I expect from you, you're going to have here a prop put here, assuming it is there. So that we save, we are going to have another prop here. Then we are going to have another prop put here, yeah? Then we put there a tree coming from here straight to here, then coming to this point, yeah? So I need you guys to create an L. Move like this, then move like this. All together. So you go in your trees, that's the assignment I want to leave you with. You cut a tree which comes from here, it reaches here. We nail, no, like L. We are making an L, eh? You put these props going inside, also this going inside, all together. Then put another prop here, eh? Then you make sure you have a distance from here because you are going to do excavation, eh? It should be at least, it should be like 800 from here, or 1 meter, eh? From here, eh? Then you put this, don't tamper with your square because already it has taken time to do the square. Then you put that prop that is crossing from here, make sure it goes slightly below this for easy. Then again you put a prop that is going to connect here. So you have got an L of profile here, an L of profile there, an L of profile in that corner, and an L of profile there. After we have that L, which we are going to work out, that's something I'm leaving you with. We are going to go on the prop, assuming this is a prop that is going to move. Let's get this. So our prop is going to move it up a bit, we see. Let it move from down. From down here. Someone, now you are not acting as a prop here, you carry here. Also he carries there. Assuming this is my prop, other people, you pick that other prop there. Of course, it's going to have a support here. Eh? Going to have a support here. Also put that going up. Some other people put it there. That's why sometimes we put the whole site, we surround it with what? Props. This is a demonstration. Yeah. So this corner, they are supported by this. At this point, someone else, you are the one still working, but we shall have a tree. Eh? This is what is going to happen. Are you seeing? So you will have another tree here. Eh? Because we have limited trees. If we had trees which are many, we would just move around the entire site. Eh? But if they are limited, you are going to cut like from here, put there what is supporting. Also cut here to use that. Eh? So now, I already have my external wall here. Eh? Get me the nails, because now I'm going to work it on here. Eh? Corner is. So I'm going to measure from this, make sure it's here in the center, eh? But move it up. I want first set. Eh? There are two methods now. Some people who are conversant with the center lines, he can first look for the center line. Because I have the external, I can get the center line. But when people are building, most workers prefer edge of the wall, where they are going to tie here and they tie the other side. Eh? So me, I'm going to maintain this. But I want to get the excavation of the foundation. So what I'm going to do, I'm going to measure here 200. Are you seeing it here? So meaning that the wall is starting from here up to here. So this is my brick walling when it's starting from outside going inside. But we want excavate, we say that it should be 2 times the breadth of the wall. So what I'm going to do, I want to put here 200 this side, and from here I put another 200. So the total is going to be 600. So I'm going to have what we call, here I'm going to have 400 this side, and I hit here. Make sure whatever is touching is like what? Now, to make sure it is different from this, I'm going to curve it like this. Eh? Yeah? So that someone will know that if I'm excavating, I'm putting a rope on this. Then again, I'm going to measure from here going this side 200. All together? So I put it here. And also mark it like this. Yeah? So this one which is here is going to be a building nail. This is the building what? Nail. This one which is here is going to be an excavation nail. So when they are going to excavate, they put ropes here and you do the same the other side, and people are going to follow this one here. Doing what? Excavation. This is what they are going to excavate. All together. So someone at least can stand here and do the building and do everything. So what you are supposed to do now, you have understood that. So you are supposed to do this, do it there, and you put lines for excavation of the external. You have understood that? So that's how you do that. So that's the assignment to finish. The trees are there, everything is there. So that is how we set out a house. After getting the squares, removing all errors, then you do the excavation, people start building. Now these are what you call profiles. Here, these trees. Eh? If you have many trees, now if you had very many of them, we would make sure that they move the entire site. Eh? And they are the ones which are permanent. After that, these ones which are in the middle, these ones will move them. These other ones. Eh? So now this reference goes to this point, and we remove these other ones, and we call it proper set house. That is one way you can set a simple house anywhere without any tool apart from the tape measure and trees and the hammer. But we have other methods. We can use machines and any other method that you can use for setting. But this is a simple one for small houses, which you can always utilize when you are doing that. So for today, that's it. So the assignment is you complete the setting out. The trees are there, everything is there. Put there the condo, make sure that I find everywhere what I've told you done. Now question. Yeah. And we finish the assignment. It will be problematic because you're going to lose the squares. So you have to use these ones here. So use that and we finish.